Welcome.
Thank you very much. Thank you very much. So I can take over, right?
Right.
Okay, right. Okay. Hello, everybody. And I think I'll share my screen. Just sorry. Yeah. Yeah. So hello, everybody. Those joining, I'm sure. I don't know if some of you are now waking up or if you are ready for your weekend. Yeah. But well, I'm Ebenezer Agboso from URFU University, senior lecturer here. And, I'll be taking you through something little, just a brief conversation on one of the interesting topics in the modern day, when it comes to technology and when it comes to the next level of app development as is. And yes, all right. So I'm Ebenezer Agboso from Ghana, senior lecturer in the Department of Big Data Analytics and Methods of Video Analysis. And I teach the master's program IT Innovations in the Middle East, one of our master's programs in English. So it's a privilege for me to be here with you today. So first of all, as I said, my topic is on MLOps. I'm sure some of you have seen the topic. What's MLOps? I think for me to make the class quite interactive, I'll actually be opening the browser a bit just to show you some things. I'm sure some of you have heard of the term DevOps. It's a popular terminology. Maybe you come across DevOps, especially maybe if you are into programming or development, you might have a fair idea of what DevOps is. And it's a popular terminology used by lots of developers. Some people, for example, programming the back end of a website, an app, the front end, and then we have the whole process together. That's development operation. And this has been quite popular for quite a long time by app developers or team of developers come together and usually like to use a platform to coordinate their whole process of development. So, for example, maybe if some of you are aware of tools, one of the popular tools developers work with is GitHub, using Git and GitHub. And I don't know if you are interested, but then if you want to go further in the development world, it's a good idea for you to have a GitHub account. GitHub is a repository, and it's a repository. It's more like a place where people store code, where people store works privately, and where developers can coordinate as a team. So you can have a repository which is private for you and your team only, or you can have one which is public. People around the world can have access to it if you're looking for something related to. Well, let me just open one of these. So anybody can have an account. We can go to Google should have a GitHub repo accounts. Even the big companies also use GitHub for all sorts of projects. And so you're able to create a repository and then create a project inside of this repository, and people you can share this. You can make it public, which means that people from all over the world can access it. For example, these are Google's public repositories, but they should have a lot. They have about 2,400 projects running, and there should be more than that because there are some private projects. Like most people start working on a project privately, and then they end up publishing it publicly. So that's usually how it works. So you find for different languages, different. It depends on the repository you're working with. Some of them are maybe limited to certain languages here. So So this is a repository, and GitHub is one of the popular ones. There's another one called Bitbucket, which is popular for in the DevOps world. I'm sure there are other ones people. Now, so in the DevOps world, this is basically the DevOps framework is more or less like an approach to programming in simple language terms. It's an approach to programming. It's just it's a way you would manage the programming process. The same way we have project management. Project managers have their tools and their formats for managing a project. So in the same way, in the world of software, and if you want to be an IT manager, project manager for the software, you can read a bit more into DevOps. So, so with the word DevOps, MLOps is a term that is gaining some a lot more knowledge in recent times. And what could be the main reason? One of the main reasons for that is the fact that there's AI. Artificial intelligence has become really popular today. Now, so I'm sure some of you are all aware of AI. AI, when people hear AI, the first thing people's minds go to is robots. The robots are taking our jobs. The robots are taking over and all of that. But it's not as it is. I'm sure maybe that's a different conversation altogether. But when with the world of AI, there are so many benefits of AI today. We can look around and see, even just picking our smartphone and say Siri, call Siri, or OK Google, or Index, Alisa, and all of these platforms. Just by saying, using your voice, it's able to trigger something for you, trigger an action, and just by realize that it helps us in our shopping experience. We're able to have recommendations, even products that we didn't even think we need. They're usually recommended. You go to your Netflix account, you open your Netflix account, you find lots of information right there. And that's how it works. So AI is basically any technique which enables computers to mimic human behavior. That is the basic or the general description of AI. We want computer human activities. And within AI, there are so many methods, so many techniques, so many algorithms that exist. It's only quite interesting that in more recent times, AI has gained a lot of momentum. If we should look back to some years ago, maybe about 30, 40 years ago, you can read a bit about the AI history and then the fathers and then the pioneers of AI, of the artificial intelligence world, first developing the perceptron and realizing that this thing wasn't working because there were so many challenges with the AI's foundation, because they realized that it was only later on that researchers began to realize that there wasn't enough computing power. So when we look back, for a certain time in history, there was the AI winter. It's called the AI winter, meaning that there was not a lot of development in AI. There was no, even researchers who wanted to publish in AI conferences, machine learning related conferences, publish articles in those kinds of, alongside those kinds of works. What happens is that when they publish a work related to AI, people didn't really respect it. Everybody went back to their usual other areas of research, focused on that, and left AI. So for a few years, there was no research in AI. And then another revolution was sparked in the AI community, and people began to see the importance of it. It's not until recently, quite recently, let's say 2012, that we had the method of deep learning. And machine learning is, first of all, it's a subset of artificial intelligence. So it doesn't stand on its own, it's a subset of AI. It's one of the ways of teaching a computer to mimic human behavior. So how does machine learning work? All we have to do is we just give the computer the answers to a question, and we say, this is how, for example, we want to distinguish between a cat and a dog. The machine has to understand how a cat looks like. So we have to give it so many examples of cats, different angles, from different angles of the face, from different colors, different breeds of cats, different breeds of dogs, different breeds of different angles of photos of dogs. And we let the machine learning model, the machine learning algorithm of our choice is going to try to figure out what makes the model work. What makes what makes a cat, what makes a dog, just by looking at the pixels and reading and seeing a pattern. So it's trying to identify that pattern. The same way when it comes to disease detection, if we go back and see just the recent COVID-19 pandemic, lots of people trying to find ways of detecting COVID-19 in people, in anybody, just by maybe the voice, your cough. If you cough using a smartphone, we'll be able to know if you have COVID or you don't have. I mean, that's quite a difficult task to do. All we have to do in this case is, as a machine learning person or a data scientist, what you do is that you're going to get lots of people who are not sick and people who are sick. So you take their voice notes, or maybe you just let them speak for some time. Maybe just cough for 5 seconds, and you record all of this, and you separate these data, and we give it to the algorithm to try to learn to see the pattern, so that it's going to understand how does what makes someone's voice or cough voice know that the person has COVID or not. That's another interesting. So these are some of the interesting areas, and it's quite recently that deep learning is one of the AI revolutions, deep learning, which is really, really interesting and is being used a lot these days, has taken over, especially in the world of images, that is image computer vision, that is detecting objects in images. And even when we take a look at translation apps, I don't know, maybe if you look back, if any of you use Google Translate, you can see maybe there's been a big difference in the past 5 years, or maybe past 6 years, in using most of these translation apps, because they're able to translate better. They don't just look at translating word for word, but then they're also able to understand context. Of course, AI has a very, very far journey ahead, but there's been a lot of advancements. And when we take a look at, I mean, some people are more interested in what we call AGI. That is, AGI is another area. It's artificial general intelligence. The hope that AI will be like human. I mean, that it will be too difficult to distinguish, but that's a different world altogether. People are aiming to get that. But most experts will tell you that just focus on, there are a lot of areas that AI can work in, but we are choosing to aim for really, really high. Like we are aiming for the moon when we can actually aim for the earth and the skies. So there are lots of problems that AI could solve. And today AI is solving a lot of problems. And so just taking a look at the methods, we can see the different kinds of methods that work in the different types of AI. In especially, we have the multi-layer perceptron, which is a neural network which has many layers. And we have the convolutional neural network, or CNN, not the TV stations. And then we have RNNs, recurrent neural networks, and all these other types of algorithms, or their techniques. So you can find a lot of them. And well, if you want to get into the world of AI, or you've started a bit of machine learning, well, most people would recommend you to go with Python programming, which is advisable because that is the industry standard. So if you want to learn AI, or you want to be able to know how to program AI, it's best to start with Python. And don't be scared. I can advise, my advice is that if you want to start with this, just give yourself 1 year. Don't rush with it. Take your time and not only learn, but maybe attend some master classes, listen to a lot of podcasts, listen to a lot of conversations around these real-world applications, because you're going to realize that in the beginning, you may not understand a lot of things. You hear so many big words and big terminologies, which is out of your field. But then you just go over and maybe give yourself some time, cut yourself some slack. After some time, you'll be able to get it, and give yourself some months. 1 year is quite long, but then 1 year, in a year, you should be a guru, like a master of to a certain level, of course. There are different levels in AI. People who are more into research and more into the deep side of it exist. Yeah. Then there are also people who are just interested in applying AI, for example, in healthcare, in maybe building apps for building solutions to help in detecting or predicting certain things. People in finance, the stock market, crypto prediction. Of course, that's it. Those are quite interesting areas. But one of the things we can understand is that it's difficult to predict human behavior. So human-related stuff are quite difficult to predict. Human behavior can't predict some of those things. But I mean, we try to predict. That's why there's a popular researcher, George Fox, he said all models are wrong, but some are useful. So not every, because a model, when we say a model, we usually use AI and machine learning and deep learning and all these things to build models so that we pass new data through this model to give us a prediction or an interpretation. Now, these models may not represent 100% of every possible thing. They may not be able to see the details of everything, but they try. So that's why usually there's a, when you look at any prediction model, they will say there's a percentage confidence. There's a probability that I'm right. I know this is a dog, but I'm 70% confident that it's a dog. So confidence levels are also important when we do this. So it's just read more and then expose yourself to more content. Now, so in machine learning, usually this is a simple workflow. Just how most people approach it. There are so many other ways of doing it at a big level. And, but from the start, maybe you want to start working with it, and you can install Anaconda. There's a software called Anaconda. It helps you to set up Python very well. And you install Anaconda, and it helps you to set it up. Then we have what we call virtual environments. A virtual environment is basically like this. You have your computer. Let me give a scenario. You have your PC. You want to have many accounts so that you can install different softwares on different accounts. You have maybe 3 accounts. So or you have 3 users. You have maybe you and your brother and your sister, for example. And you want everybody to have access to their own accounts on their PC. What you do is that you create 3 accounts, which are 3 accounts on one PC, and you can have your software installed on your when you log into your account, and you have your softwares. But those same softwares may not be available in your brother's account, or also maybe your sister's account. So you have your tools you use when you log in. When you log out, your brother logs in or your sister logs into their account. They see totally different things, custom for them. So that's the same concept with virtual environments. We create virtual environments in Python so that we can work. For example, you want to work in computer vision, text analytics, and audio stuff related to like deep learning and audio for machine learning for audio. They use different packages. In Python, we have packages or libraries we use because Python does not come with everything you need. So you have to set it up and you have to install packages or libraries that you can have access to some special tools. So, you can create a virtual environment for specifically working for computer vision tasks, another environment specifically working for some other tasks. So it's also a good thing. And so we set up virtual environments, and then we're able to access our Python installation. And one of the tools also for easy working with Python is Visual Studio Code for an interface for programming and for coding. It's quite convenient to work with Visual Studio. Okay. So these are some of the tools. Of course, everybody has their preference. I cannot say use this or don't use it, but these are some recommendations. Now, what happens is that you have your data set. You have data. Maybe, for example, you work with a financial company, and then you want to be able to know which of your customers you should give discounts to or not. How do we know that? We'll have to build a model that will help us maybe detect to see some patterns in the customers and know maybe these customers deserve or don't deserve. Or in a bank, you look at a bank also will do the same thing to know if a customer deserves a loan or doesn't deserve a loan based on some data. Because we're going to look at so many things. And now there's also another area in AI which is called ethics that people. It's a debatable area also. People talk about whether to add like gender into the data set or whether to add race into the data. That's also another conversation altogether. But for some people think it, but it does not really. It might not really be important. It might not affect your results well or something like that, or you might discriminate. But that's a different conversation altogether. Now, so with the data set, you pass in your data set. Now, one of the best things you have to do is that we split our data, training and testing data. Because, for example, you have been given 10,000 rows of data. What do you do with it? And you don't use all for machine learning to train a model. You're going to have to split it. And usually, we split the data because we want to keep some so that the model, we want to keep data. And this data will be data that the model has not seen before, because the data we use the training data, and this data is what the model has seen already, so it knows how to predict based on the data it has seen. So we want to keep some data. Usually, with this most people like to split 70 for training and 30 testing. So that's how it's done. I mean, it depends on the amount of data you have. Some people use 80% for training, 20 for testing, because more data is needed for training. So it's better to train on a lot of data. So you pass your training data through the algorithm, and then you get your model. You get your model, and your model will have maybe an accuracy. You're going to test your model. We test the model to see, we test the model on the data that the model has never seen before to see if it's able to predict, and the results given to us will determine whether someone deserves a loan or not. And what happens is that we would verify to see the accuracy, how accurate the model was. So if it had maybe 70% accuracy, maybe we have to make some changes. Like we go back to the drawing board and we change some things in our model. Or sometimes you might not really get a good accuracy, and which means that if it's a very critical system, are you going to depend on a model that is giving you low accuracy? For example, in healthcare, would you a model that is able to predict and give accuracy of 70% or 50%? You wouldn't want to risk it because it's a very critical area of healthcare. So we don't play such dangerous games with AI in these areas. Okay. Now, just before I jump there, so we build these models, but most of the time models are built and that's all. Okay, I've built a model. It works. I have a good accuracy. What next do I do with it? Well, easy recommendation: put it in an app and use it for something. Yeah. So most people build AI models and then they sell them as apps, or they sell the model, or they integrate the model into apps. And that's the goal of MLOps. It's DevOps, but for machine learning. So development operations, but machine learning related. So basically, we want to. It's a structure. The same way it's a framework. The same way DevOps is a framework. MLOps is also a framework where we define a set of software components, like for realizing machine learning pipeline function. Basically, we want to give the structure or the flow for how to put machine learning models into apps. And so it's most of these processes are what we call iterative. That is usually they're incremental. Well, we make improvements over time. We don't just leave it. We don't just design, build it, and then put it there, and that's all. You have to improve upon it. And I'll talk about why we improve upon that. Now, when it comes to DevOps, there are different types of ways of putting your model. As I said, from here, you've built a model. You have your model here. It might be a file. It might be a certain file. We have the different types of files we can save the model as. So we load it and use it for predictive purposes. Now, there are many ways we can build models. We can use models on the web. That is for machine learning ops purposes, MLOps purposes. One of them is batch prediction, where you basically it's like you train your model offline, of course, and then you dump the results of the training in the data set in a database. So this is basically the structure. This is the client piece. Anybody's piece, you can access the server, and then the model information is hidden in a database. Of course, it's not really the best, but it kind of works. It works for some kind of data when you have small data coming in, like when you are not working with like a huge data and lots of data or lots of input data, for example, like bank data or image data. It's just simple, like for example, you want to put in some 4 values just to check to give you a result. Yeah, I mean, we want to know if someone deserves a loan. You just put in 4 values and click, and it gives us a result. So that's basically how we can do that. And the issue is that because it has low latency and then it does not scale for complex input types. For example, complex input types could mean images, sound data. It might not be the best option here because of how it's built. Yeah, this framework it's a framework or it's an architecture for machine learning, MLOps. Yeah, so you might want to ignore this one in some cases when you're working with some types of data. Yeah. Another one is model in service, whereby it's inefficient for big models, but what happens is that you place the model in a server, and then maybe you make a request to the server and then receive results. Yeah. But what happens is that sometimes the web server may not be able to handle the model. In some cases, because maybe the web server was built, it's like maybe it's an Amazon web server, or now these days, Amazon web servers and Google web servers may be able to handle. Or if you can't pay for those web servers, you need some web server for a particular at a cheaper price, and then you realize that the web server is not able to host your kind of code or kind of model because especially when there's no GPU that's existing, because some models require GPUs to run, especially when you're working with images and large complex kinds of data. Without a GPU, a CPU cannot really do the work for you. So sometimes there might be complications with it. But as I'm saying, all of them work, but then sometimes you have to look at your budget, you have to look at the kind of data you're working with, and you have to look at the kind of tasks you are doing. And we have models as a service where the model is hosted on a different web server, and then you make a request to your website and receive results, and the predictions are released back to the client on the PC or on the tablet or something. Maybe you are working with a warehouse company, and you're working on a tablet. Yeah, you would need something like this. These are usually dependable, and even though there might be potential latency issues, it's one of the maybe widely acceptable ways of deploying machine learning models on the web. And after that, you're able to have access to it anytime you need, because the model is sitting on a web server somewhere. So the website just makes a request to them. Anytime you enter some information from your tablet or your smartphone, it goes to the server, checks, loads the model, comes back, and then releases the results, the prediction results. So that's one of the other ways of doing that. Also, it means that there has to be some compatibility between the two systems, where the model is sitting and where the server, your app server is, like your front end or back end system is sitting. So usually we have to do that. Now, all right. So deploying your apps. Well, first of all, there's I'll come back to that. First of all, there's one solution. There are many solutions for deploying machine learning apps. There are so many ones. If you know about Django and all that, like Python and Django, because I'm talking about Python related solutions. So Django, there's Flask, which is also another solution here. I mean, this class is not this lecture is not going to limit you to only one type, but rather I'll try and tell you different types here. So there's one called Flask, which is quite interesting also. And if you really want to do some deep work, Flask is a better option because it gives you flexibility. You're able to build apps and then kind of, or not kind of, but you're able to have some maximum level of control over lots of areas of the app, the back end, the front end, and yeah, but especially if you are into React JS, like React or Node.js, development of apps, and you want to put a machine learning model into your app. Well, it's quite simple. And you can use Flask, and then we can use something like TensorFlow JS, JavaScript to hold we can place our models into into Flask, and then use TensorFlow JS also work with it, so we can see a demo of an app. There are many kinds of apps like that you find along online here. An interesting one. No, I don't want to. Someone that's going to open my camera. Some of these ones. For example, you want to build a yoga app or something like that. Maybe one exercising app to correct people's posture. We have body pose estimation models. Machine learning models are able to estimate correct pose of a person. So you have to train it on different kinds of exercise. So maybe you're going to train a model on what does a plank look like. So you have lots of pictures of plank. You have lots of pictures of different kinds of exercises. Like, yeah, I'm trying to remember some of the names of the exercises, but squats and all of that. So you train the model on different pictures. Means you need a lot of photos, and then you have to label the photos and label the points, the body points, and train the model on that. So you put it in an app, and the app will help you to know if your pose is okay or you are doing plank the right way. And there are lots of applications that people have built in some of these things running on the web. Well, I can say it's not the easiest of all, but then because it's quite new, so there lots of people are trying to look for alternatives to make it easy for people for people like us to create models, create apps, and then put them online. Now, so Streamlit is also one of those alternatives. I mentioned Flask, which is one of the popular ones. And one of the other ones is Streamlit. Now, Streamlit is an open source Python library that makes it easy to create and share custom web pages for machine learning and data science purpose, or just to create a Python, a front end for your Python app. Yeah. So Streamlit at the moment, I mean, the difference is that you can't really control a lot of things in Streamlit. It's limited in control, but it's a really good start if you want to learn how to build websites for Python apps based on Python. It's quite simple to work with. And well, the good thing is that there are cheat sheets that exist online, so you'll be able to find cheat sheets and they teach you how to build Streamlit. Now, I'm going to open Streamlit. Streamlit.io is the main website. I mean, I highly recommend it to you. You can join the Streamlit community also. And it's used by a number of companies also because of how it works. It can be used for maybe in-house stuff. You're working in a company and you want to use a model in-house, maybe for internal purposes, not external. Yeah, right. Just something small app running in your within the company. You can build it on. It's quite simple. So this is just a code, for example. First of all, you have to install the Streamlit library. When you install the Streamlit library, the rest is history. All you have to do is just import the Streamlit. And if you know a bit of Python, you would say like import Streamlit as ST, and then we import pandas. This is just another package for working with tables and data sets on the, and be able to load it and visualize our app. These are a few examples of what is possible with Streamlit. So the best place, there are a few apps that have been loaded online that work. One simple example. One example. another interesting example. So, well, we have, I think, also view the source code so that we have an idea of what it's all about. So as I told you, it's good to put your code on GitHub, and then the code is going to be on GitHub, and I'll show you how it's all done. Yeah. So there's the app that is running online. It's public, so we can have access to it. Yeah, I think you put in some text information, maybe a whole paragraph of text, maybe from the works of Shakespeare or works of any other popular writer, and then you get your data, and it's going to give you some results. Yeah. I didn't get any text. I just have to go online and copy some text, and yeah. So that's how the app looks like. You can realize that the apps have a similar look because you can't build the UI the way you want to build it custom. Not so much. But people are still trying to build solutions for that, build some themes and all of that. So this is one of those apps. So we put in the text, and then we check some parameters, and it's able to give us some results, and we can download the results. That's fine. You take a look at the code. You can see usually the code sits somewhere right here. Yeah. It's pretty interesting. This is an example of one where the model is sitting on a server, and then they are just accessing the model in the code. See somewhere here they access the model remotely from another service here, so that makes it easy for them. They don't have to load any model file anymore. Now, a number of Streamlit apps I'll show you, but I just wanted to do this. So, and first of all, we work with Streamlit. You need to have Python set up. You need to have installed the Streamlit package. And well, one of the good things is always to sketch out your idea by designers. That's you draw your app, and you sketch it out, and using any of the popular tools for developing UI or designing UI, wireframing or prototyping UIs. Then installing the package. If you know about Python package installation, it's really quick install. And then you code your app logic, and then you save it in a file. So you save it in a file, and usually the file have a file name, and then we just in the command line we run something like streamlit run file name.py. So the app name, or maybe the name of the app where the app is held .py. We run that code, and it's able to run. Visual Studio Code makes it easy for us to work with that, so we don't have to worry so much. So how do we do it? Yeah, so this is how we build apps, and then we deploy it into the cloud. I'm building an app in Streamlit here, Python app, because maybe you have some really cool Python code and you want to put it, you want to give it a front end. What we do is that you have a folder, you write your app name. You don't have to use app.py all the time. You can use a different name, but a Python file. I mean, you might first work in a Python notebook, and then when you are done, you can create your app in a Python file, because we don't need a Python notebook where we're deploying things in the cloud. So Streamlit has a community cloud. A community cloud basically means that we can create an account there on Streamlit, and then load files, load apps right there. And so what do we do? We have to also have Git set up on our PC, and then Git helps you to be able to send files from your PC to GitHub. So our Git is also it's basically what we call version control. It's a version control software. Working as a team, you need to be able to find a way of pushing your files and then pulling updates. So those are the main two main words you come across: pull and push, merge also. So for example, you're working on a project with me, far away in Mexico, I'm here in Russia. What do? I make some changes to the code in those days, maybe you have to send it by email, and then we have to make changes and see where I made a change. It's very difficult. So Git came into the business, and well, let's create the concept of version control, so that I can make a change and you can make a change, and we all push our changes. And when we merge the code in the cloud, it's going to see where our changes are. So it will prevent conflict of code and errors. So it helps with that. And usually we also have, sometimes there's a team manager in these cases who manages the code and make sure that everything is checked well before they merge the code together. And then after that, I can have the updated version and pull it back to my local computer to see the new content that you made, the changes you made. So yeah, push it to Git, and then Git helps us to push it to GitHub. So we push our code to GitHub. In GitHub, we actually have to create a repository for that, where we want our code to go. Then automatically, well, we have Streamlit, but Streamlit, we can set Streamlit up in a way that is gonna pick up our GitHub, and that's also, I'm gonna just show you how it's done. Then what happens is that if I make any change and I push it back to GitHub, Streamlit will automatically detect that there's a change in the code base, and it's going to update the code. Yeah, so that's what happens. That's one of the easy ways. And this is what we call CI/CD. That's continuous integration, continuous development, continuous. It's CI/CD. It's one of also the languages you come across. It's a continual process. DevOps, that's basically what DevOps is about. When we continue to build and we continue to deploy. So basically, once we are implementing, we are deploying, integrating our code instead, we are deploying it. So we don't have any problem with stopping the server and then making changes, uploading it here. It's all connected, so it helps. The workflow is quite easy when we do that. You have to make your change, update. Maybe you decide to add a new button. You push our code to GitHub. You get Streamlit to automatically do this for us. Yeah, make sure everything's okay. So that's how it works. And I want to show. Well, the good thing is that anytime you come across any package or any tool like this, they have readmes and they have documents that help you to prepare apps, to know what to do. So in the first place, before you actually work with Streamlit, you have to sign up, create an account. And when you are signed in, I've cleared at the moment, I have no apps running here. So somewhere in your settings, right here, and link your GitHub to give permission for Streamlit to have access to your GitHub. So I have my GitHub, for example, if I have my GitHub. All I'm gonna do is I have my repositories that I've created, and for example, this one is an app that runs here, and it's also on my PC. So just to show you, the app is here on my PC. I use Git. I've installed it, so I use Git to move the app to GitHub. Right here, something like that. And then how do I create an app here? So because I've linked my GitHub to Streamlit, which makes it easy. So all I have to do is create a new app. Now I create a new app and just go back again. Probably this is better. Create an existing app. Create an app from an existing repo. So this is what I'm gonna do. It's gonna say these are all it's able to have access to all my GitHub, public and private. That's quite interesting. If there is any folder that is linked to anything related to Streamlit, just load it here. And then I enter the name of where my main app is. So for example, this one, the main app is called app.py. So I have to. Yeah, sorry. So realize that file does not exist. It's able to know. So when I do app.py, everything is okay. And then if you know our branch as well, like I mean, classically in GitHub, the main it's called the main branch here. And because of time, I don't think because you need to. It's I don't think I'll be able to go to everything for you here because this has to do with machine learning. This has to do with a bit of web development and also a bit of coding and a bit of working with tools like Git. So my recommendations for you are to know Python, know how to work with Git, and know how to work with GitHub and Git, and then know how to use Streamlit is just going to be easy for you because once you know how to work with Python, know how to work with Git and GitHub, the rest is easy. Yeah. So we're able to create an app right inside here. You deploy the app, it's going to run and then make it. Now, okay, so just to show, I'll try to give a simple demo, but yeah. Now, when you build a machine learning model, there's something you have to take care of. In MLOps, you have to be careful of. The fact that you build a model doesn't mean that's the end. Now you can sit down and relax. Work is done. Usually, you realize that the model works, and after some time, it loses. It doesn't work as it used to work. That's quite interesting. There are so many reasons. We call that model drift. When the model begins to drift from its usual performance or model decay. It's referred to as the degradation of machine learning model performance over time. For example, it might not be able to even detect a lot of things well as it used to be. Because, for example, even with us as human beings, you realize that you change, maybe you become like older. So if you have a selfie app or like a filter app or maybe an app for detecting biometric, your features are going to change a bit. No, that's yeah. So the reason why a model will have to work well is that you have to make sure that we put in new data into the model to retrain the model. So the best alternative is to retrain the model so that it works better. So we use new data that we gathered because you're a company, you work with data. What do you have to do? You get new data coming in, or even if it's an app for facial stuff. Facial detection or emotion detection or something like that. Yeah. Of different people, different races, different cultures. You find that the model might not work so well all the time. So what do you have to do? Anytime someone uses the app or you get more data and then push it back into the model to retrain the model to improve its performance. So how do we deal with model drift? The same approach we do as in Streamlit. This is just an interesting recommendation that I thought about. This is the user accesses the Streamlit app. What we can do is that we can have a database so that when we'll be able to store new transactions or new data through the app and push it into our app, this data, and retrain the model and push it back into Streamlit so that it works well. Yeah. So model drift is an important, or model decay. That's when a model begins to work not so well as before. Yeah. So it's something we have to take a good look at visual machine. My slide ends here, but what I'm going to do is I'm going to show you a brief how we'll be able to run. So this is I have an interesting code that I built. But because of time, I may not be able to go through everything. Okay, let me open another file right here. New window. New window here. Well, see on my code. I have a lot of tasks I need to do. Just to give you an idea of what I'm going to do. I haven't. I mean the file, but anyway, yeah, I have another copy somewhere here. Basically, this is one interesting one. So this is really in the machine learning world. There's a popular problem of detecting, trying to distinguish between these three flowers: Iris setosa, Iris versicolor, Iris virginica. The data set exists online. So with your little knowledge in Python, and we know that this kind of problem is a classification thing. They're trying to classify that something is whether the flower is Iris setosa or it's Iris versicolor or Iris virginica. Unfortunately, this is not image related. This is dimensions. The flower dimensions have been given. So this is how the data looks like. We give the model the data inputs, and we give the model the answers. So we say learn how. So we are saying learn how Iris setosa looks like, learn how Iris virginica looks like, learn how. It's just like teaching someone how to drive. This is what something looks like. This is what another thing looks like. This is what tacos taste like. This is how Rusas tastes like. Sorry if I hope I'm not butchering the names of the foods. So different kinds of foods, like you know how it tastes like. So your tongue is used to differentiate it. So when someone makes some fake tacos, you be like, oh no, this is not real tacos here. It's not. It doesn't taste like tacos. It's maybe shawarma, something like that. So because your tongue has been learned, your tongue has been taught to understand over time. I mean, you were born in your home, you eat all these kinds of food, different. So you're able to distinguish. In the same way, we give the examples of the data to the model. So this is, and if you, with a little knowledge in Python, and because of time, I'm just going to, oops. So, well, there are so many things we do. In Python, usually you import your packages you need. Now, one of the popular packages for machine learning in Python, for basics, to start with, is scikit-learn. It's what scikit-learn, or SAIKIT-learn. It's a really popular one for machine learning in Python, where you can run different types of machine learning algorithms. Now, in machine learning, there are different types of problems. We have classification problems. We have clustering problems. Some problems are like this. You don't want to you are trying to classify, distinguish between one or the other. So all we have to do is give, for example, in this case, it's a classification problem. So we're going to load up the package. We have to install the package. It's called scikit-learn, and they will usually teach you. Every package will give instructions on what to do when you need to install the package. You install it. And for example, I'll just use a terminal just to show the terminal. Just a terminal. So I'm working here, I'm running my code here. So I can see it. So I can do like pip install scikit. I'm sure you know, maybe some of you know this, to install the package. This is the complex way, or you can use Anaconda to install it easily. Load your data with pandas right here and time, and just take a look at the data, explore the data to see what are the patterns in the data. We have 3 classes of data, and every flower is being given the petals and the sepals. So the petal length, that's the flower, like the petal, the length of it, and the length of the sepals. So all of them have different dimensions. So that's one way of distinguishing between processes. So we take a look at the data, go through the data, and then we use scikit-learn to split the data. As I said, we have to split it into training and testing, and we use the training set for training the model, and we later use the testing set to verify that the model is. One of the algorithms for this task I used was called k-nearest neighbors, and k-nearest neighbor is KNN. That's usually the name. It's KNN. It's basically one of the algorithm that helps you to group data by the closeness of how close they are. You can plot the data and it's going to group them based on how close they are to the center. Yeah. And if you can just read a bit more about nearest neighbors based on data proximity. And, because like if information is the same, for example, people of the same characteristic will be in the same group. That's the simple logic. So using K-clip nearest neighbor to build a model, we build a model, and then what we do, we train the model, and then when we are done, we test it out to see. So usually we'll see the test results. It has 98% accuracy, which is really good. So we can test the model here. So we test the model right here, and then we save the model. We can save the model as like a file, like a pickle file or an H5 file or any of these binary files. And later on, what do? We open a Streamlit. We create a folder, create our app. Also have to have this requirements of text, because when you want to, we'll have to push our files to GitHub and then push it to and then so that GitHub Streamlit is going to pick it up. So we need to have a requirements file, because in case we use any other packages, we have to list them all in this requirements text file. We don't have any problem. Now we import Streamlit as ST, and then just as I've shown you right here, Streamlit has some interesting ways of working. It helps you to design a website. So st.button, name of the button is hit me. st.download button is a different kind of button. Streamlit checkbox, and all of that. So this is basically how we put things together during these interfaces, designing our interface. So we design the interface right here. That's not the app. And the next, the final step would be to go. I think I have this running on my PC already. Yeah. So, this is how we run the app. Well, I have to. I'm going to do something. It's already running, so I'm going to stop it right here and just show you. So this, I'm working in this directory, as you can see, using Visual Studio. What do I do? To run it locally, so that you know that my model is working, I would use, as I said, Streamlit run. And then the name of the file is app.python. That's app.py. I'm going to run this. And all my model is basically, this is my site. It's just a simple website. The title of the site, this some HTML contents to hide some other stuff. And then I'll say, create a sidebar like that. Have some contents right here on this on the side of the page. And then I have a container which is going to hold all the main information. It has some text and has text inputs, a text box, another text box to hold the we're going to hold the 4 columns of data that we need. This. So I showed you that we need these 4 data to predict. So I have 4 text boxes, and then a button that's going to click to predict. So if it is submitted, convert that information into integers and create an array or a list, two-dimensional list, and pass it into the model to predict. If the prediction result is an iris setosa, then give me this picture. If it's that, give me another one. If it's that, name. So this is what we do. That's pretty much run. Just run it. This is running it locally. Yeah. MLOps on from a local version. Yeah. So this is my app, and this is how it looks like. And if I put in some information, so this is my sidebar, as you can see. That is the side of the project. st dot sidebar. And the container will be this right side. So I put in 10. So like 10, 1, 5, 5, and click predict. It's going to tell me the flower is Iris virginica. So it puts in these details. That is this stuff here. the details we get from the table, it puts it in and it passes in through the model. Model is here for the model to predict. The model I created is here now, so it's the profile. If I read it in, and then it's going to just pass the data into the model and get me the result. And if the results are what we want, give me this. Let me change the values to 1 and predict. It says it's iris setosa. So if these are the dimensions you have there. So the same way we can apply this to a banking app. You can create it for a bank or for a business. If your information is this, click predict and give the results, no loan or loan. Okay. So in general, yeah, this is how we work with it. Now, just to finalize my presentation, at the end of the day, we have to deploy this online. So what do? We create a GitHub. I'll be ending in a few minutes. So we create a GitHub repository, and this GitHub repository. So somewhere in GitHub, if you have your account, you create a new repo from here. So create a new repository, give it a name, save it. It doesn't have to be. It can be public or private. It's okay. Once you save it, you go to your PC in your app. Yeah, and the rest is history. Just use GitHub to push your code there, and then the rest. And after that, we open. We're going to have to open. How do we call it? Streamlit, to find the app, the repository we are working with, and then we deploy it and we get a web app. Now, another way of also working with apps is right here. Yeah, a good example of is another place we can deploy an app is using Hugging Face. But I'm just going to tell you that this is one of the places you can also do that. So yeah, I think because of time, I'll not. It's quite a practical task. So unfortunately, I won't be able to have all the time to do that. But what I can say that if you are really interested in this area, it's just me introducing you to some of the things you can do. Streamlit is one of the recommendations I can give you to check out and do that. And that, I think it might be beneficial for you. Contact me, you can get in touch with me and you might know how to continue. Yeah. Sorry for piling everything on you. I know it's practical, so it needs some different times here.
No problem.
Yeah,
no problem, Mr. Ebenezer. Thank you very much for this precious information. So I invite the audience to contact Mr. Ebenezer. He's a senior lecturer at the Ural Federal University in Yekaterinburg, one of the top universities of Russia. And he runs, he's a senior lecturer. This university offers master programs in this field in English. So you are very welcome, whether to take the master degree program or whether to take some of the tracks of the summer courses in which Mr. Ebenezer also is involved. So thank you very much, Mr. Ebenezer. I hope you will meet some of the participants of the audience in Yekaterinburg within your students.
Very much. Yeah.
Thank you very much.
We hope to see you in IT innovations in business. Yes.
Thank you very much. Bueno, estimados amigos, entonces les agradezco. Pasamos por chat la siguiente conferencia, que es en 26 minutos respecto a energía clásica y alternativa por un doctor en ciencias de la Universidad Aeroespacial de Semana. Goodbye then, and have a nice weekend, Mr. Agboso in Yekaterinburg. Thank you very much.
Gracias.
Goodbye. Goodbye.